Super. So without further ado, everybody, welcome to a webinar that is a collaboration between ESP and the GEC. A little bit about the global energy community that I am also a part of and will be today's host. My name is Irena Goryans, and this is a global engineering community, global energy community. So what do we, what are we, just in short? We're a group of energy enthusiasts, volunteers. We dedicate our time for these projects that we do without any compensations, but in the hope of building a global energy community for all of us, including the enthusiasts from all around the world. Our vision is to be the biggest decentralized energy community in the globe. And the mission is to unite independent global citizens around the goals of affordable and clean energy. So in short, what do? We gather experts. We have a network of experts. We try to connect them with each other and between our attendees, our guests, and ourselves. We host webinars. We record podcasts. We post global energy news, anything that is actually interesting for us or for our viewers. We collect knowledge and share that knowledge with anyone that is willing to listen and collaborate. And also we post memes. These are some examples of our posts that you can find on Facebook, Instagram, LinkedIn. Yeah, pretty much anywhere, but we're still grasping on the TikTok idea. Yeah, maybe in the future. There are a few cooperations that we actually do as online and our offline presence. So Illuminum is one of our first cooperation. It is a world leading resource of trending high quality information for energy sustainability, policy, climate change, and more. So if you are interested, you can go and check out our website and just simply Google Illuminum for more information. Also, we were a part of the Energy Youth Day as a part of International Gas Forum for more than 1 year, since this is actually a place where we all kind of got interconnected from all parts of the world and got the idea of actually starting a community where we can share our knowledge and everything that we gather upon our ways. And the latest, it's Leipzig University in Germany, where one of our amazing co-workers actually did her thesis and did a session about global energy community and the role of youth in global cooperation. And we have also worked with NIA, the New Energy Advancement Hub. You can connect to them over LinkedIn or Instagram and learn a lot from this company. We are hoping to have even more productive and interesting projects with them in the future in this year. And the Energy Sustainability Program, of course, that helped today's webinar come to life. This is a little introduction for all of our other team members. We had a really cool music on this video. So sorry that you couldn't hear it, but you can find us on YouTube and listen to it as well. Oh, thank you very much for your patience. You can use this link to go to our information tree and find us anywhere, almost anywhere on the internet. So the person that we are actually gathered here today to listen to is our Madalitso Chimpeni. He is a climate tech innovator and energy entrepreneur. I'm very excited to let him get on his way with our today's topic, and that is the significance of biofuels and e-cooking in the transition to clean cooking. So have a great time. Just yep, the floor is yours.
Oh, okay. Let me just share my screen. I hope everybody can see me and hear me as well.
We can hear you loud and clear.
You can see my screen.
Yes.
Okay. All right. Good evening, everyone. I don't know if it's good night or evening. I am Madalitso Chimpeni. I am a climate tech innovator and an entrepreneur. Uh, I am a co-founder of a company called Bebu Energy. We developed a helix type wind turbine in collaboration with an Argentine partner, and we are actually deploying this technology in Malawi for wind microgrids and standalone installations. We're also looking to expand into mini hydrogrids utilizing the same technology. It's a multifunctional technology that can be utilized for both hydro and wind energy. But I'm not here to talk about my enterprise. I'm here to talk about the significance of biofuels and e-cooking in the transition to clean cooking. I've been working in the clean cooking sector for about 5 years now. I've worked with different biofuels, briquettes, biogas, ethanol. I've researched bio LPG, bio CNG. I also ventured into the wind energy sector, like I said, but for now I'm in the wind energy sector. Um, Clean cooking is a crucial issue that needs to be addressed in specifically developing countries. So there's parts of Asia, there's Africa, and parts of South America as well. So in the majority of these countries, we rely heavily on biomass fuels. So, like from this picture, you can see there's a woman that is cooking on I think that's a three-stone fire using firewood. So this is a common narrative in the majority of the African countries. So there's about 2.5 billion people that use fossil and biomass fuels for cooking, and that should be roughly about 600 to maybe 900 million people that are in Africa that are using fossil fuels and biomass fuels for cooking. So that is one of the major leading causes of carbon emissions. Um, Biomass burning stoves produce approximately 1 billion uh, tons of carbon dioxide into the atmosphere. So this does not only cause in-house pollution, but it also exacerbates the effects of climate change by increasing the temperature of the globe, in so doing, accelerating climate change. So clean cooking has been introduced in recent years to address this issue, to reduce the overconsumption of fossil fuels as well as biomass fuels in the cooking sector, so as to reach net zero emissions and fully transition to clean energy in basically all sectors. So what is clean cooking? So clean cooking is basically the use of energy efficient and low or zero emissions technologies and fuels for cooking. So we have existing solutions uh, for clean cooking that have been developed and are still being developed up to date. We have e-cooking appliances, things like pressure cookers, things like induction stoves. I'm going to talk about those ones. We have LPG or CNG, LPG, liquefied petroleum gas, or CNG, which is compressed natural gas. So they're both harvested from the earth, I should say. But there's also another version of CNG that is bio CNG, and it's a form of purified biogas. So they call it bio CNG because it has the same content as CNG, only that it's produced from biogas. So we have biofuels that include biogas itself, briquettes, ethanol, bio CNG, bio LPG as well. So there's also another existing solution that is fuel efficient biomass stoves. So like the one that's in the picture, it's called a GEC. That's something I saw in Kenya. I think if I have any Kenyans here, uh they can recognize it, that it's a brand that was developed in Kenya. So we have those ones. And then in Malawi, we have something that we call Jidede Zumbaola. It's been widely adopted. There's about 2,000, over 2,000 of them that were distributed in the country. So that's a bit of progress. So I'm going to mostly talk about biofuels and e-cooking because they hold the largest potential to help us transition from the use of biomass fuels to cleaner fuels in cooking. In biofuels, we have fuels like briquettes, biogas, ethanol, and bio LPG. So I'm going to firstly talk about briquettes. This is the first fuel that I worked with when I started venturing into the energy sector. That was just after I graduated from college. I have a Bachelor of Science in Biotechnology. It's they're not 100% related, but they sort of do have elements that intertwine. So after I graduated, I couldn't get a job, so I started looking for things that I could do on my own, and I went into the energy sector. So the easiest thing that I could start with was briquettes. So, like I said, briquettes are the easiest thing that anyone can do. You can do it at a household level and cook with them. So they're a direct substitute to charcoal and firewood because they use the same mode for cooking. So you have your own stove there that you use for charcoal. You can basically just substitute that for briquettes, and you're going to cook properly. But I do not consider briquettes a as a working solution to energy transition in clean cooking. I consider them as an intermediary solution because they are produced from biomass waste like sawdust, what's this, wood chips, agricultural residues. But when you burn them, they also produce carbon dioxide into the atmosphere. But there are some briquettes that have been improved in quality that do not produce any sort of smoke, but still they do produce a quality, an amount of smoke that can still be harmful at a certain level. There is also a process that's called decarbonization, where you have a briquette like that that's in my picture. That is a that is uncarbonized briquette that's just basically made from raw sawdust or wood chips. So they burn that to remove all the carbon, just so you can have a bar of charcoal, so something like that. So in that process also you release carbon dioxide in the atmosphere, but you're subsequently preventing the emissions of carbon dioxide in the household. So that's the advantage that those ones have. So briquettes have not really been adopted widely in households, and the biggest challenge with that is that briquettes um, might not are not as efficient as the most efficient charcoal that's on the market. It's because um, to to produce a very efficient briquette, you need machinery. You need machinery that can compress the briquette at a very high pressure so that it's intact, that when you put it in your stove, it doesn't crumble when it burns. So I've seen a lot of entrepreneurs that do briquettes with handmade machinery or hydraulic machines, and that is a way to go, since most of them do not have the right equipment to produce the high quality briquette that's required to compete with charcoal. But it does not provide a direct solution or a direct competitor to charcoal, because when you put the briquette on the stove, it cannot burn as efficiently as charcoal does. So the majority of households do not uh, prefer to use briquettes. They prefer to use charcoal. If you give them briquettes and charcoal, eventually they're going to stop using the briquettes. They'll start using charcoal. So briquettes have been widely adopted in industries. So in industries that use heating to process things. So in Malawi, we have a company that produces chicken feed. So they use a lot of briquettes to process their chicken feed, and that works for them. But for households, it's a big challenge. So just to tell you what I'm talking about, I've done this before. I initiated something I called the Mpebu Initiative, where I worked with a number of women, the women that you see on the right. I trained them and we started making briquettes. We'd make briquettes and then fill them in a box and sell them. So the largest challenge was that we were making the briquettes by hand. They weren't compact enough. They didn't have enough quality to compete with charcoal. Yes, they did burn well, but they couldn't burn as well as charcoal. So my deduction was that to actually uh, have briquette as something that can uh, catalyze a transition from biomass to cleaner fuels, you need to have an industrial approach with briquettes. You need to produce briquettes of a higher quality. So luckily enough, there's a machine that can do that already with briquettes made from sawdust. So sawdust has a natural um a natural ingredient that's called lignocellulose. So when you compress that at a very high temperature, the lignocellulose is going to melt and stick to the sawdust material, and that creates a really good binding material that makes the quality of the briquette really good, and it can compete with charcoal on the market. But the problem is that you need a lot of investment to get that machine and to get to produce that um, uh, on a mass production. Yeah, so briquettes do have a potential to help the transition to cleaner cooking, but we need to have an industrial approach to have these things roll out on the market, distributed to households, have them available in at distributor points, as well as have them available for industries to use. The next fuel that I'm going to talk about is biogas. Um, Biogas is basically an indirect substitute to biomass fuels, because unlike charcoal, you cannot use the same stoves. You need a whole different apparatus. You need a biogas stove, you need a biogas digester, you need a biogas you, everything. You need waste to produce the biogas. Um, just give me a second. It's been widely adopted for institutional use, especially in Malawi. A lot of people, a lot of households that have farms, not households, but people that have farms have installed biogas systems in the country. Even schools have biogas systems that have been installed in the country. Even in places like the USA or even in Europe, they have really big anaerobic digestion plants that produce biogas, and then they purify that to bio-CNG and feed that into a gas grid or generate electricity with it. The biggest challenge with biogas for adoption uh, for domestic use is basically the availability of waste. So you need a lot of waste to produce biogas. To produce biogas. So with the average waste that a household can produce, it's nearly not enough. Okay, it's not enough to actually generate enough biogas for cooking, because the household needs about 1 cubic meter of biogas um to cook with per day, and that's not enough. As you can see in the picture, that is a biogas backpack of 1 cubic meter. I've worked with these before, I remember. Even these ones are nearly not enough for a household to cook with. And the problem is that they come with a low pressure, so you need a pump to constantly pump the gas to a stove so that it can work properly with at a good pressure. But biogas does have a potential for domestic use. Um, and this is something that's called bio-CNG. So when you purify your biogas to uh, 80 or 90% methane, you have a really good chance of having a fuel that is just as efficient as LPG, and that can be compressed into cylinders or produced or piped into a gas grid to distribute into households. So this is a project that I worked on some years back in 2020. I collaborated with a few experts, some from the University of Surrey, some University of Portsmouth, and another company called Engas UK. They had developed that thing that's in the picture there. It's a biogas CNG plant. I think I talked about that one. No, it's a purifier of biogas. It purifies biogas. It upgrades biogas to bio CNG. So the advantage of this technology is that it reduced the steps to upgrade biogas from 4 steps to 1 step. So that was the advantage of the technology that they created. We wanted to install this technology in Malawi, mass produce biogas, and then channel it into pipelines, like how they do with water. So basically, that is the best way to approach biogas for domestic use. You need to produce the biogas, add value to it, upgrade it, and then distribute it directly to the households instead of asking them to generate the biogas on site. Uh, that is a very flawed approach. It it it's unsustainable. It might not eventually work. So what I'm talking about is something that's like that, a portable domestic digester. That is something that I built sometime in 2020. As you can see, that's a drum. It's a 200-liter drum, and these are the tires, and there's the gas in there. I could make about 40 liters of gas per day, which was only enough to maybe cook some eggs and maybe boil some water for tea, but it was not enough to for cooking for an entire household. Um, and also the waste, the amount of waste that we were producing as a household was a household of about 6 people, was really not enough to make 1 cubic meter of gas. So portable domestic biogas digesters are ideal for supplementing other clean cooking fuels. Let's say you have electricity, or you have LPG, so you can use this portable domestic digester to maybe cook something like something else. You have your main meal, and then you're cooking something else. It's also an excellent solution for managing household food waste. So instead of throwing it away, you can just put it in the digester and generate a little gas, so that you can use it later. But biogas is good for institutional use, but for domestic purposes, it's better that the biogas is purified to something like bio-CNG that can be used for cooking in households. Or even in rural communities, you can put that in a cylinder and then sell it to households where they can use it for cooking. So this is an AD plant that's been installed in South Africa. I take that they generate electricity with it, but this is just that just shows that we have this technology in Malawi. We have these technologies, not Malawi, but we have these technologies in Africa. They're here, and we can learn from what South Africa did, because even in Kenya they have something like an 8 megawatt uh, biogas anaerobic plant that they use to generate electricity. I think in North Africa they also have those ones. So um it's something that was developed in Europe, but we have it in Africa, and it's only and it's only a matter of time that it could be scaled up to reach many parts of of the continent. We have so much bio waste that is just thrown out. Uh, we could recycle that, generate gas for cooking, and also for electricity, but mostly for cooking, because uh, that would serve a really um, it would serve highly in terms of clean cooking and transitioning to cleaner fuels. So I'm going to talk about ethanol from here. Ethanol, uh, we all know what ethanol is. Some of us drink it. Like it's Friday, so I'm pretty sure after this I'm going to have some drinks. But ethanol can also be used for cooking. In Africa, we have an estimated 450 billion liters that can be produced from crop residues alone. So that is a lot of ethanol that can be used for vehicular transportation, generating electricity as well, and cooking. So I'm mostly going to highlight a company in Kenya. I had the privilege to see what they were doing with ethanol. It's a company that's called Coco Fuel. It's a very well established company. I don't know how they did it, but it's a prime example of utilizing clean energy, or I mean clean fuels, for clean cooking. Um, they put a lot of investment in infrastructure to have a proper distribution line. They have tanks uh, that distribute ethanol into dispensers. So these dispensers, when you get the dispenser at a shop, you can have a canister like the one on the right. So you can get that canister and fill it at that thing. They call it a cocoa point. It's like an ATM, but it doesn't dispense money. It dispenses ethanol, the same ethanol that we use for hand sanitizers, uh, the same ethanol that we put in our drinks. You can actually get that with that from you can actually get it in the canister and then fill it into the burner to cook your food, to cook your relish and anything else that you want to cook. So it's a prime example of when investment meets a really good business model, um, to push a clean fuel into the market. I understand that the technologies are not actually developed within Africa. I think they're imported from India. Even the ethanol is imported from India, but they established a system that works really well. They have about 100,000 households that are subscribed to their product. They use their product daily. It's really amazing when I saw what they were doing, and I was inspired. I mean, if we could replicate that across the world in many countries that do not have fuels like this, that do not have access to clean fuels for cooking. I mean, we could revolutionize the cooking sector and hasten the transition to cleaner fuels. So I just wanted to highlight that specifically on ethanol. But we do have a lot of biomass. We do have a lot of crop residues in Africa. Uh, we just need the right investment and the right equipment to get this thing rolling. Ethanol has the potential. I never thought that people could do this with ethanol, but here they are. They're doing it. They're distributing it like how you can distribute LPG, how you can distribute um, um, how you can distribute CNG in cylinders, only that they have canisters for that. So I mean, that's a good way to go. I was really excited when I saw that. So I also want to talk about bio LPG. So this is an emerging fuel. It's an emerging fuel that's still in the piloting phase. So basically, bio LPG is a synthetic gas a synthetic form of LPG that is produced from biogas, biodiesel waste of syngas. So what they basically do is they split the chemicals apart and then they rearrange them to make propane or butane, which is basically LPG. So you have biogas, which is largely methane. So they use pyrolysis to break the molecules apart and then rearrange them to make propane and butane. Those that are chemists, I think they they pretty much understand what I'm talking about. So this is a sustainably sourced LPG that is not produced from petroleum, but it's produced from biomass. It's produced from biomass, only that it's converted and then scientists do their stuff and voila, you have LPG, the same LPG that you can get from gas stations. You have the LPG that's produced from biomass, and you can use that just as well as LPG for cooking. I haven't really heard much about this technology up to date, but this is something that we were also looking at. We wanted to try piloting bio LPG in Malawi. Unfortunately, we couldn't go forward with that. But maybe in the next 10 or 20 years, or maybe 5 years, who knows? Uh, Somebody might pick this up and we might start a pilot for bio LPG. So e-cooking has been there for a number of years, ever since the introduction of electricity. We've had uh, elect electric stoves, we've had electric cookers, we've had microwaves, rice cookers, but e-cooking is a new concept that utilizes energy efficient appliances, something like pressure cookers, the one that's in the picture right there, uh, pressure cookers, induction stoves, rice cookers as well. So these are energy efficient technologies that do not consume a lot of electricity uh, for cooking, and they largely target urban and peri-urban households because that's where the electricity is. But also, I think e-cooking is going off grid as well, targeting households that have solar home systems that can support electrical appliances like these. So it's an emerging there are emerging technologies that I believe are catching on really fast. As you can see, that's a Tefal pressure cooker that's made in France. Actually, it's made in France. It's made in China, but the company that manufactures it is a French company. They manufacture it in China, but it has custom made names for African cuisine. So I think that's Swahili. That's basically Swahili. So as you can see, these things are already catching on in Africa. This is a sample that the company sent to me. We're actually working together to get these things distributed in Malawi. We're also working together to develop an e-cookbook for Malawi so that they can have a guideline on how to use pressure cookers. So I think we also want to have our own language on the buttons instead of having Swahili. So this e-cooking uh, has been introduced to also tackle the issue of biomass fuels, of the over dependence on biomass fuels, charcoal and firewood. You see in many households, even urban households, they do have electricity, but they perceive electricity as something that's really expensive. So instead of using electricity for cooking something like cassava or beans or fish, any sort of food, they still turn to firewood and charcoal because they perceive that it's less costly uh, if you compare it to cooking on electricity. But in the long run, charcoal is actually very expensive. It's actually getting more and more expensive now that the trees are getting scarce and now that forests are being protected. So charcoal is actually very expensive now. We had this at home at my parents' household. I think they've had it for 2 years. They never used it until I went there and showed them that this thing is actually very efficient. If you're cooking cassava with this thing, um, you're going to take about 1 hour if you're using charcoal. But if you're using a pressure cooker, it only takes about 15 to 20 minutes and you're done. You have your cassava. So these are just my trials, several trials that I was doing on my own. Like I said, I'm working on an e-cookbook with Group Seb as well as Mix. It's a an organization from the UK. So we're working together to develop an e-cookbook for Malawi. So these are what you call them, the bananas. They're fresh bananas. I think it's a very common cuisine in Africa, in West Africa as well as East Africa. They just get the fresh bananas, cut them up, and cook them. Uh, it took me about 20 minutes to finish cooking the fresh bananas. But if you're cooking on firewood and charcoal, it's going to take more than an hour. So electric cooking has been introduced because it's more efficient. It takes less time. It's more cost effective if you compare it to biomass fuels. So this is the cassava that I was talking about. So that's the before and that's the after. It only took about 20 minutes to get my cassava, I don't know, finished or done. Yeah, so um e-cooking has one of the largest potential to possibly substitute firewood and charcoal in households that have electricity. Apart from that, we have things like induction stoves and electric fires. So if you basically have these things in your household, you wouldn't find any reason to use charcoal and firewood for cooking because these things are actually more convenient and they will cost you less in the long run. Uh, you might incur a high cost when purchasing them, but in the long run, they're going to save you on the energy expenditure as well as the time that you spend cooking. I think this is actually very and advantageous for women who spend a lot of time cooking with firewood and charcoal. If these technologies are introduced in the households, they would take little time to cook, hence they'll have a lot of time to do other things, businesses, um, anything that can improve their livelihood. Um, I mean, people might say that it these things are expensive in a way because uh, the one that I got from France should cost about $70. So in my country, that is a lot of money. But there have been incentives, something like I don't know if you know about pay as you go. Pay as you go, you can employ pay as you go to pay for these things in installments, where you get to use the thing and then paying little by little. Because I was also talking to another company that's called, is it I've just forgot, ATEC. They have an induction stove that has IoT embedded within it. So it's an IoT induction stove where they insert a chip or a SIM card. So you can use the induction stove. If you haven't paid for it for that month, you're not going to use it. It's just going to automatically switch off. So in that way, you're going to incur um, less expenditure on the purchase whilst using it. So it's very affordable for even rural communities can adopt these things. I think it's worked with solar home systems. Um, Solar home systems have been introduced in the past 10 years, and now they're being widely adopted in a lot of rural communities. They can afford the upfront cost, so they use a pay-as-you-go model where they pay little by little. If they haven't paid that month, they get the electricity cut off. So you can actually employ the same business model and distribute these things in urban and rural communities as well. We actually submitted a bid for the modern clean mod, modern cooking facility funding. It's a funding by the Norwegian government. It's a lot of money actually. They're providing up to 2.5 million euros. So as you can imagine, there's a lot of funding that's going into the clean cooking sector. There is that push to transition to better and cleaner technologies for cooking. So how can we advance clean cooking in Africa or in less privileged areas where they do not have access to cleaner fuels? Um, the first thing is increasing access to uh, clean cooking fuels and technologies as well. So, like I said, um, pressure cookers are not a thing in Malawi. You won't find them anywhere because people don't know what they are. They do not have access to pressure cookers. So the moment you provide access to these technologies, people are going to gradually accept them and use them. So like I said, even biogas, for you to get to use biogas, you need to have a biogas digester in your household to generate your own gas and use that. So instead of doing that, you can centralize production of biogas and then distribute bottled biogas to the households so that you increase access to the technologies and the fuels. The other thing is sensitization programs. Like another instance, I said when I went back to my parents' household, they had a pressure cooker that they hadn't used until I came there and I told them that this thing is actually more energy efficient. You can use it to save up energy as well as the time that you can take to cook. So sensitization programs are really necessary, and also the e-cookbooks. E-cookbooks have been developed in Kenya, in Nepal, I think in Uganda, in Ghana, in Tanzania, in Zambia. They developed e-cookbooks where it provides guidelines on how to use electric stoves, pressure cookers and induction stoves, so that mm, you ease into the adoption. You don't have much trouble utilizing the technologies. You know exactly what needs to be cooked at what temperature, at what time. So things like those are really important in advancing clean cooking across the continent and also the globe. Secondly, another thing is developing business models for scaling down the cost of clean cooking. I talked about a pay-as-you-go model where you can have people pay in installments until they finish the full payment for the products. And also, I talked about cocoa fuels. They have they they developed a business model that for ethanol that sells ethanol at a very affordable price. Households have uh, actually not gradually, but it didn't really take time for them to adopt to the fuel because one, they had access to the fuel in their own communities. They could just go to a dispenser and then get the fuel, and two, the cost of the fuel was reduced. So those are some factors that can improve the advancement of clean cooking across the globe. But I want to emphasize on this one last point: producing fuels and clean cooking technologies in country. I think that provides more advantage if you have the technologies produced within the country. So if you have all these clean fuels being produced within your country, imagine having bio CNG being produced within your country. You have ethanol that you can produce within your country, all the technologies that support clean cooking, all these electric pressure cookers, um, all these induction stoves, having the capacity to build these things, these technologies yourselves in your own country, um, is a great advantage to advance clean cooking because now um, you don't have to incur importation or custom cost for the products. You have them within your country. The only thing that you have to pay is value added tax. We wanted to set an assembly plant for electric pressure cookers in Malawi. Unfortunately, the companies that we work with said it couldn't work because something about um, the the cost of production is increased if you move to another country, which means they have to export some of the products. You have to import some of the products from where they're manufactured. So it's just a matter of having all those industries well developed that you can source all the raw materials from within the country without having to import anything at all. Um, so about the opportunities that are in clean cooking, the opportunities that are available for young people or any energy professional that wants to push clean cooking for energy transition. We have a growing market for clean cooking solutions. There are a lot of sensitization programs that are going around for people to transition. So people know that they're clean, they have better options for cooking out there. But where are they going to find these technologies and these fuels? It's up to us to distribute these things, produce these things, generate them, manufacture, innovate, and provide access to this growing market for clean cooking solutions. We also have funding opportunities, a lot of funding that's going into clean cooking. Like I said, the MCFA funding opportunity, they're providing up to 2.5 million euros per company. So if any enterprise, if you well established and you have your financials properly, you have a good traction, they can give you that funding to scale up your operations to either distribute LPG, e-cooking appliances, or maybe set up a plant to generate your own biogas, anything else that has to do with clean cooking. There are also job opportunities in the clean cooking sector. Um, uh, Sorry, I'm going to talk about Kenya a lot because it's like it's like Wakanda. It's like Wakanda for clean cooking because they have it all going on, honestly. They have non-governmental organizations, they have companies that are well established that are developing technologies left and right. I went there for the Youth Energy Summit or the Africa Energy Forum, and also went there for the for the Africa Climate Summit, and I'd find all these young people that are working in the energy sector. Hey, what are you doing? I'm an energy officer for something, something, something. I'm an energy liaison for something, something, something. I'm the energy business development officer for something, something, something. So it's a very vibrant industry. Clean cooking is a very vibrant industry in Kenya. It's well established. They have the right structures that can push it forward. So I really love if a lot of developing countries had this sort of mindset, this sort of advancement going on as well. Because if you have all these sectors that are working together and young people that are working in the sector as well, it's going to ease the push to the advancement of cleaner fuels on the continent and the rest of the world. We also have readily available proven technologies. I mentioned about bio-CNG. I talked about pressure cookers. You want to distribute these things, go ahead. You just have to talk to a supplier or talk to a manufacturer. Anybody that's interested um in electrical appliances or LPG, I have manufacturers and suppliers that are willing to find a market in the African continent. I think I'm just going to try to drop my LinkedIn, and you can talk to me. I can link you up with those manufacturers. There's a huge market, and they know there's a market. They just need people that can provide that link. So we have readily available proven technologies. You want to distribute? Do you want to make them yourselves? Um, you only have to see what they're doing and just replicate within your own countries. You have it within yourselves. I'm an innovator. I believe in self-sufficiency and making things yourself, making things on your own. I build wind turbines. I worked with an Argentine partner, and uh, we work together to improve the turbine. And this is something that we're prototyping now in Malawi. Not prototyping with that, but we're actually building it to an end product in collaboration with a university in the country. So we have it within ourselves to innovate, to build these technologies. I made biogas in my backyard. I made briquettes. So imagine if I have all those technologies, if I have access to funding, if I have access to equipment, there is a lot that I can do. There's a lot that you can do as well as an energy professional. I think this is all that I wanted to present. I think I'm at the very end of my presentation. Thank you so much.
Thank you so much for your presentation. It was really interesting to hear about so many innovations and opportunities actually that are in this sphere of clean cooking that sometimes we take for granted actually. The electric appliances that somebody may be using every day in their homes are sometimes not so how do you say distributed as we might think. So we will start with the questions from the chat first, and then I see a hand that is going up from Onyekachi. But just a second. So the first question was, what could be approximate capex for the machine that can produce high quality briquettes from sawdust?
Oh, just an estimate. It should cost about $15,000 upwards. Uh, I think that should depend on the capacity as well. But I've seen very small ones that are built in China that you can get for maybe 5,000 or 7,000, but they're not for mass production, they're for very minimal production, but they do produce the same quality of briquette.
So it would be more for like a household or a few households, the machine that you were talking about.
The machine that I'm talking about is for industrial scale. So you're
For
looking at
industrial.
a whole area, like a whole city, you can produce enough
Mhm.
briquettes to feed the whole city. Yes.
Thank you. So the first one of our guests that had their hand up is Onyekachi. You can turn on your microphone and ask the question.
Okay, thank you. And thank you so much, Mr. Madalitso. That was a brilliant presentation. So I would say that clean cooking is an aspect of the whole energy sector that I'm most interested in. I find it quite fascinating. And my question is in two perspectives. The first is gender, perhaps gender inclusion, and then the second is behavioral change. So when you talk about clean cooking and introducing it into maybe a community or developing nation, you notice that women are they are the ones that use most energy for cooking. So when it comes to cooking, especially in developing nations, like women are the ones that always do the cooking. They're the ones that are always in the kitchen. They're the ones that are always getting the energy, maybe the firewood and the rest, especially in rural communities. So I also see I saw during your presentation that you had you included women from rural communities into like developing some of the briquettes, which is a good innovation. Like is a good thing that you're doing in terms of empowering these women. But then I would like to ask, like when it comes to including women into policy making around clean cooking solution, like what is being done regarding it, saying that women are the ones that are actually affected by this whole issues around clean cooking. So when they use this traditional means of cooking, they're the ones that their health are affected. They inhale the smoke from the firewood and they understand how this traditional means of cooking affects their health. So how can women be included into policy making to further like make the cooking space more inclusive for them? And then when it comes to behavioral change, I would like to ask how you could like encourage people, especially in rural communities, to adopt these clean cooking solutions, seeing that most people in rural communities, especially in developing countries, they they are already used to using basic means of cooking, that is the firewood. And if you're to go into these communities and then you try to enlighten them and educate them and try to transition them from using basic fuels to cleaner means of cooking, they kind of frown at it because this is what they would say that their ancestors have been using and nothing has happened to them or their environment. So how do you instill this behavioral change on these people in rural communities and help them to understand that clean cooking solution is actually for their own betterment, for their good health and also a good environment? Thank you.
Okay. Thank you so much for your questions. I can tell that you're very passionate about gender, and energy. Um, the policy issue is really hard for me to answer because I'm not really a policy guy. I'm more of into the technical stuff, but I'd really love to get into policy making. It's something that I'm looking to get into in the next coming years. But I think a lot of these technologies are built so that they favor women in some way. So, for instance, electrical appliances, like I said, pressure cookers. So, if you have a pressure cooker in your household, as a woman, um, the family is going to expect you to light a fire, or if it's firewood, to cook anything, cassava or yams or anything that you can cook with a pressure cooker. But if you have a pressure cooker in the household, you have that burden relieved off of you. Or instead, you're going to utilize the pressure cooker and only spend like 10 to 20 minutes to cook it. All you have to do is prepare the cassava or yams and then put them in the pressure cooker, and it's done. So I don't know if there are any women that are having their say in the policies that are being made for clean cooking. But what I know is a lot of these clean cooking technologies favor women, and in a way that they provide ease for cooking, as well as provide them with a lot of time to do a lot of things that they need to do to improve their livelihoods. And also the issue of rural communities adopting to cleaner technologies. It's a tough thing to do, to convince somebody in the village to stop using firewood, that they just go into the jungle, chop a tree and then cut it in bits, and then they have their fire, to start buying fuel. That's really hard to do. That's one of the biggest challenges I had with briquettes as well. So we produced the briquettes, but then we couldn't go to rural communities and sell the briquettes to them because they had firewood in their house. They had firewood in their communities that they could just go to the jungle and get for free. So what you have to do is you have to provide technologies that are attractive. When they see these technologies, they say, no, you know what? This is too much time. I have to go into the forest to get firewood. I have to do this. I have to set up the fire. Why not just use gas to cook with it? Why not just use a pressure cooker to cook with? So it's like what they did with solar home systems. They introduced solar home systems into households. People were using candles that were cheaper. People were using kerosene lamps that were cheaper. But when they saw that the solar home systems were actually better, they could charge their phones with it. They could light the entire household with solar home systems. They started gradually adopting the solar home systems, and with the pay as you go um payment model that was introduced, it actually made it so much cheaper than for them, because in Malawi you pay something like $1 $1 per month, $1 per month for a solar home systems, for something like for 3 years, if it's not 2 years. So imagine somebody in rural communities, they only have to pay $1 per month to have their solar home system supply electricity to the household without having to buy it upfront. They're going to pay for it little by little. So if you introduce those incentives with clean cooking fuels as well, uh, you'll see that a lot of rural communities are going to gradually transition, because I don't think they enjoy fetching firewood, or they enjoy spending a lot of hours lighting up the fire. They don't. Only that they don't have any other option. But if they did have a better option, they would transition really quick. So I think that's all I can say about that.
Thank you for your answer. And we had another raised hand from Netsante Taya Said, but we are having a little bit of a problem connecting. For some reason, the guest was out of the chat, but I think we have them with us now. Yes. Netsante, if you would, as you would please, you can turn on your microphone or write your question in the chat. We're ready to hear from you. Or maybe just in a second. If anybody else has any question, feel free to turn on your microphones, ask the question, or raise your arm. Promise Ikpuri, please turn on your microphone.
Yeah, good evening.
Yes, hello.
Can you hear me? Good evening.
Yes, we can hear you.
All right, thank you so much. I think this lecture was really insightful. I have two couple of questions to ask. I am calling from Nigeria. You understand the terrain of the Nigerian economy. The economy is actually plagued with the issue of low electricity. There's actually no access to electricity, particularly in the rural areas. So my question is, how do we adapt, or how adaptive or is it for rural communities to actually transit from the traditional means of cooking to e-cooking systems? Because the truth is that less than 2% of rural areas, they have no access to electricity. So that is my first question. Secondly, talking about the use of e-electricity systems or e-cooking systems, you mentioned something like pressure cooking. Are there health risks to using pressure cooking, particularly in cities where you have access to solar systems and a bit of electricity systems? Are there health risks? Because I am actually looking at the economics of the health risk of using e-cooking systems, electricity cooking systems. So are there health risks with using this kind of systems? Thank you so much.
Your first question, you talked about access to electricity. Is that right? That rural communities do not have access to electricity. So
yes, definitely.
So e-cooking would be a challenge. Is that right?
Yes.
Yeah. So e-cooking would be a major challenge in rural communities because of access to electricity. But there've been trials to utilize e-cooking from solar generated power using solar home systems, so they can power the electrical appliances for cooking. But I don't know where that those trials led to. Um, but EPCs are generally not built for rural communities. They're meant for urban and peri-urban communities, or just communities that have access to electricity, uh, because those communities are the ones that actually consume charcoal at a really large scale. I think you actually agree with me that rural communities don't actually cook mostly on charcoal, they use firewood. So it's the urban and the peri-urban areas that consume a lot of charcoal for cooking. So these electrical appliances for cooking come in as a substitute for charcoal that is mostly consumed in these urban areas, in these peri-urban areas. Uh, but for rural communities that have access to microgrids or mini grids, uh, it's actually ideal to have EPCs distributed in the communities. So that works as well. You also talked about health risks with something like pressure cookers or any e-cooking appliances. So there are no
Yeah.
health risks to e-cooking appliances. They just work as well as other electrical appliances out there. Mm, they just work. They work like cookers. They work like rice cookers. They work like uh, electric stoves. Only that they're more efficient. They save a lot of time for cooking, and they also save a lot of energy, making them cost effective.
Okay. All right. Just to add to what you said in the first question, even in the urban areas and in the urban areas, particularly in Nigeria, you find out that the cost of electricity uh, outweighs what we intend using it for. So, for example, you find out that you spend money for fuel to power your homes, to power homes, to even use the e-cooking system. So, moving away from the rural areas, you will find out that you spend more getting fuel to power electrical appliances, even in the urban areas. So I think that could be cost effective and cost ineffective in terms of adopting e-cooking systems in the Nigerian case. So what do you think about that?
No, I know you're talking about electricity cutouts. We have those as well in our country. We have those as well where we have access to power lines, but we don't have electricity because of blackouts and load shedding. Um, that's a very huge issue. In Malawi, we don't usually use petroleum generators to have a backup source of electricity. If it's dark, it's dark. You're going to sleep with candles. That's how it works. So in your situation, yeah, EPCs would actually be very expensive if you're using them from an electricity backup that's coming from a petroleum generator. So the only way that it would work is if the actual electricity is back, use the APCs to cook on them. But then even if you're cooking with electricity using other electrical appliances like a normal cooker, a normal electric stove, you're going to use more electricity if you compare it to using cooking appliances like induction stoves and pressure cookers. So you're still going to save energy and save time if you use the pressure cookers when you're cooking on a backup of petroleum generated electricity.
Okay, all right. I think it's better. Okay, all right. Thank you so much.
And thank you for the question. We have Anya Pachi with her hand up again.
Okay, hi. So you spoke about a challenge that a challenge for the biomass, manufacturing biomass. You said that we don't have enough waste for manufacturing biofuels, sorry.
For
So
biofuels,
yes, biofuels.
that we don't have enough waste.
Yes, you said something regarding we not having enough waste to manufacture um enough biofuels
No.
during your presentation, or maybe I'm
Okay.
mistaken.
No, go on with your question. So it's
Okay. So you can see in my country we have an issue with plastic waste. So we have these PET bottles that you can't easily recycle, and then they end up being dumped into um, like maybe drainage systems and causing so many environmental issues. So my question is there a way, is there a technology, an existing technology, or are there people thinking about like producing a technology whereby they could like turn some of these waste could be e-waste or PET bottle waste, plastic waste, into maybe fuels that could be used for cooking? Is this something that is feasible?
Yeah, it's something that it's a technology that's been developed because um, plastic is made from petroleum-based products, right? So there's a technology that can reverse engineer any sort of plastic, either if it's PET or high density polyethylene to petrol and diesel. You can actually re-engineer it to produce LPG for cooking. So there's already a technology for that, and people are doing it. Just look it up. You'll find that there are many examples on YouTube, anywhere on the internet. There are practical examples of that. Onyek, are you there?
Yes, and thank you very much. Okay, maybe you said there aren't enough waste from household to produce certain
Yeah,
gas. So
yeah, that's what I
okay,
said.
my apologies. Okay, I got
Yeah.
that wrong. Thank you very much.
Okay, great.
Well, thank you so much for everybody. There were some very interesting questions, and I will add to it with something that was interesting for me, and I'm actually interested in hearing your perspective on it. What do you think would be the best policies or practices for marketing somehow at the clean cooking for the rural areas and the maybe older generations that have that kind of that are not keen on using some of the new products or new solutions?
Honestly, the best way is having demonstrations. I mean, what cooking demonstrations in rural communities. I haven't seen any cooking demonstration that does a complete analysis of the advantages that you'd have when you're cooking with LPG or cooking with electrical appliances or biogas over biomass fuels. Like, get your biomass fuel, cook something similar on a different sample, and get your LPG or e-cooking appliance, and then cook it at the same time, and then do a comparative analysis while people are watching. I think that would actually give people a better picture of the advantages that clean fuels and clean technologies have in the cooking industry. Uh, yeah, I think that's the biggest thing that you can do. Have cooking demonstrations and demonstrate that we have more efficient technologies.
Yeah, I heard it more than once from uh, some of my even friends and more older people than me. I believe it when I see it. So that's
Exactly.
something we
Exactly.
can adjust to this. Thank you so much for your answers and for your presentation. Are there any more questions? 1, 2, 3, sold. I hope everybody had a great time. Thank you for all the things that we learned from you today. And that's it. See you in the next webinar, and see you all of our guests also.
Thank you for
Have
having
a
me.
great day.
Thank you.
Netsante, again, with the arm up, you have the last chance to ask your question if you do want to.
Yeah, thank you so much,
Okay.
Irina. My connection was very disturbing. I don't know why. So
Yeah.
my questions are, number one, regarding this biogas, like homemade, because in Ethiopia, we implement this in rural areas, but they are not sustainable regarding sustainable because the skills to use the things, and they also damage, harm the rural community while using. So is there any means to make it sustainable and to, to prevent from harming the rural people? One question. The other one related to those e-cooking, the induction stoves, and the other e-cooking stoves. Like, I have a question. One is, how much is the energy, power consumption or power demand of those things? Because since I don't know how to say his name, Dalitso said they are efficient. So how efficient are they related to those other types of stoves? And also the induction furnace, I want to know, like, technical part. It's not like mentioned there. It only shows the minutes to cook some type of food, but it doesn't show the efficiency and the wattage of those, and also the frequency, because if it is induction furnace, induction stove, we need to know, is it medium frequency induction furnace, and what is the frequency of those? Thank you so much.
Madalitso, are you here?
Yeah, I realized that I should have logged out the moment you said, "Now, let's close the meeting." Because
We still have one more question from another participant.
Those are some really tough technical questions that I haven't really gone around because I just got into e-cooking this year. So I haven't really had that much experience. But from what I've read, pressure cookers can have can have about 90% more energy savings than than biomass fuels. I'm not sure if compared to electrical appliances. I don't know how I don't know the difference in the energy efficiency they would have. But one thing I can say is if you compare a pressure cooker to a rice cooker, the advantage of a pressure cooker is that when you close the pressure cooker, it does not release any heat, so the pressure is kept inside, so the food is cooked at a really high pressure, so you only release the gas when you're done with cooking. So that's the difference with something like a rice cooker or something like cooking on an open fire, because you're constantly releasing the heat into the atmosphere, losing heat in that process, so it makes it less efficient. But if you keep the heat inside the container that you're cooking your food in, you're going to conserve more energy, hence use less energy for cooking. So that's how it works. The induction stoves, I haven't really gotten into the technical part of it. But I can share with you a few documents that I have from MEX. They did several tests with induction stoves. Also other companies that are producing. There's a company called Real Flame. They also have induction stoves. I think they have documents on that. But so I can, I think you should just share my LinkedIn. I don't know how we're gonna do this, but yeah. So I could, you could share my LinkedIn and we could connect, and I could share you more details on those ones. Yeah. Sorry, I can answer more of the technical questions.
Yeah, sure. Well, we are actually out of time. So please, anyone that wanted to ask more questions, you can write them now in the chat, and we will answer those questions and post it or send it to your emails so that everybody can have a look at the answers from our expert. So that goes for Mariam. I saw that you had your hand up, so feel free to write the question in the dialogue, and we will definitely get back to you with all the answers, as well as often that wrote his or her question in the chat. And again, thank you, everyone. This is definitely the last question, and hope to see and hear you soon.
Awesome.
Thank you so much. Good night.
Good night.